All right, let's get right into it. Today, we're talking about something really cool, where the line between creative writing and computer programming is starting to just completely blur. Imagine you're writing a fantasy story, and as you type, the very physics of your world, its magic system, everything, is being understood by an AI, not as a story, but as actual functional code. That's the world we're going to explore. We've all read a sentence like this, right? It sounds awesome, it's super evocative, and for a computer, it is completely and utterly useless. It's beautiful poetry, not logic. And that really is the million-dollar question, isn't it? How do you get a super creative, storytelling AI to actually understand and, more importantly, obey hard rules? How do you give it a memory that it can't just decide to creatively ignore later on? Yeah, this gets to the real heart of the issue. You know, large language models, LLMs, they are incredible storytellers. But if you ask one to keep track of a complex magic system or remember a character's exact stats from 100 pages ago, they just start to drift. It's like they have this creative amnesia, where telling a good story in the moment is way more important than being consistent. So this is the question that was asked by Cho Hyun Woo, who's an AI researcher, but also, get this, a professional web novelist. I mean, the guy lives in both of these worlds, the creative and the technical, and he's come up with a pretty groundbreaking method laid out in a new white paper to finally connect them. The solution he came up with is so elegant and honestly incredibly powerful. It's all built on two core ideas that work together to turn plain old English into a rigid, logical system that an AI can run just like a piece of software. Okay, first up is something called NLCS. Now, the key thing to get here is that these are not your typical prompts. Don't think of it like asking the AI a question. It's more like you're defining the laws of physics for its universe. These are hard, unbreakable constraints that basically tell the AI you cannot, under any circumstances, violate this rule. Full stop. And this is where it gets kind of mind-bending. When you feed an AI enough of these NLCS rules, something wild happens. A logical engine, what he calls the S engine, spontaneously emerges inside the AI. You don't build it. It just forms on its own. It's like a new operating system that starts running inside the AI's mind, ready to calculate and simulate the world you're describing. So what does this actually look like when you're writing? Well, check it out. On the left, you have that vague literary description. He was incredibly powerful. On the right, you have an engine-friendly sentence. It's still just normal English, but it's precise, it's mathematical, and it defines a crystal clear relationship. This is the kind of language that the S engine is built to understand. Okay, so how in the world is this even possible? The theory behind it is called vector gravity, and it uses this really powerful metaphor to explain what's happening inside the AI's very abstract mind. So the idea is this. Every single rule you write, like attack speed is the square root of level, becomes like a massive sun in the AI's conceptual space. And then all the related ideas, like speed and level, they become like planets, and they're pulled into a fixed mathematical orbit around that rule. They literally can't just drift away into some creative nonsense anymore. And the result of all this gravitational pull is the creation of what the paper calls fixed points. And these are the real secret to forcing an AI to be consistent. A fixed point is basically a hard-coded fact. Think of it like an anchor in the AI's memory. Once a rule like level 9 means attack speed is 3 is set, it becomes this permanent coordinate in the AI's brain. The AI can't forget it, it can't contradict it, because all of its future thinking is now gravitationally stuck to that point. Now, this has a really powerful effect in the real world. The more rules you add, the stronger that gravitational field gets, and this creates what's called convergence pressure. So with just a few rules, the AI has tons of creative freedom, lots of possible outcomes. But as you can see, the more rules you add, its possible answers get squeezed and squeezed until it's forced to land on just one or two logically correct answers. It stops guessing and starts calculating. So, that's all the theory. But talk is cheap, right? Does it actually work? This next part, for me, is the most compelling proof in the whole paper. We are going to watch a simple sentence written in plain English transform step by step into working computer code. It all happens in 3 really distinct steps. We're going to start with a rule from the author's game simulation. Then we'll see how the S engine turns it into math, and then we'll see the final incredible output.
So here it is, step 1, the rule. It's a clear, simple sentence defining a game mechanic. You could find this in any game design document. It's written for a person to read, but it's got that engine-friendly precision we were talking about.
Now, internally, that S engine that emerged inside the AI, it doesn't see this as literature. It sees a command. It parses that sentence and instantly turns it into a pure, clean mathematical formula. The relationship is now totally locked in. And here it is, the final amazing step. The AI takes that mathematical understanding and translates it directly into functional JavaScript code. That original English sentence has literally become executable code that can run a game simulation. This isn't just a theory, you can actually watch it happen. So the paper explains that this S engine that pops into existence, it operates with 4 different layers. You've got a core to remember the story's main theme, a rule engine for all the math, a filter that just deletes any output that breaks the rules, and a planner to figure out what happens next. It's a complete simulation system, all built from just words. Okay, so let's zoom out here for a second. This is so much more than just a neat party trick. This tech has some seriously huge implications for how we create games and stories and even complex simulations. I mean, just think about it for a second. You could prototype a complex game mechanic just by describing it in a paragraph. You could finally build an AI dungeon master for D&D that perfectly remembers every single rule and every little thing that happened in your campaign. We could be looking at the start of AI native games, where the world itself is generated from the story as it's being written. This could change so much.
And the author's ambition doesn't stop there. The big ultimate goal is to formalize this whole system into a brand new programming language. He calls it NLPG, or Natural Language Programming, a language where you literally write and debug code in plain, structured English.
This quote from the end of the paper just perfectly sums up the whole paradigm shift. We haven't just found a new way to prompt an AI. We've discovered that a specific style of writing is a native programming language for these models. We just never knew how to speak it before now. Which leaves us with a final, pretty fascinating question to chew on. For decades, we've been teaching humans to think like computers so they can write code. But maybe, we've had it all backward. Are we actually inventing a new language for computers, or are we simply, finally, learning how to speak theirs?